All right, so Lab 8. As I mentioned, this is an extension of Chapter 7, which really delves into all of this evidence we have that the climate is changing. So for a quick review, we know the climate is changing. We have all of this evidence based on rising temperatures, melting ice, rising sea levels. So the melting ice is both sea and land ice, and especially the land ice lends to the rising sea levels, as does thermal expansion. Then we also have increased atmospheric water vapor, because as temperatures increase, you have increased potential for water uptake into the atmosphere. And then increased extreme events, so things like hurricanes, flooding, blizzards, droughts. So here we're actually looking at a map of the drought severity index. So this one shows the precipitation trend since 1900. So areas in red are where there's a negative trend, and areas in blue are where there's a positive trend. So you'll notice there's some spatial heterogeneity. So that means it's not homogeneous over space. It changes over space. And you have some areas where you have really high negative potential for drought, and then other areas where it's positive, where you actually see increased rain. This doesn't tell the whole story, of course. So for instance, in the red areas, what less rain would mean is that you can't necessarily grow crops, or maybe you don't even have drinking water when you used to, because you're getting less precipitation. And then also, even if there's an increasing trend, it can be variable. Even if there's an increasing annual trend in rain, you might see rain that you would normally see over the course of 3 months happen in 3 days. And that doesn't help you a lot when you have this really intense rain that leads to really intense erosion and doesn't lead to persistent soil moisture. And this is true worldwide. It's harder to predict rains, which makes farming and other activities more difficult. So here you can see the spatial variation in drought impacts, and then I also wanted to pull up the spatial variation in temperatures. So you can see that some areas are seeing much higher temperatures. This one is from 1900 to 2012. So some areas, so Siberia especially, some of these northern latitudes, but also a lot of South America, are seeing much higher temperatures than they used to 112 years previous to 2012. And some areas it's not changing much. So where we are, it hasn't changed much actually overall. Once again, the variability throughout the year maybe has changed, but the actual annual mean temperature hasn't changed. But when you look globally, there's very, very little blue, right? So what does that mean? It means at a global scale, we are seeing increased temperatures. So I want you to think about this. We'll kind of come back to it when we talk about climate vulnerability, because this is the exposure part. So seeing how different areas of the world, different regions, are more or less exposed to climate change. So more or less exposed to drought, more or less exposed to extreme temperatures, which is one of the components of their vulnerability. I also want to note that overall, climate zones and biomes are changing to at least some extent, and this impacts natural systems. There will be species that go extinct, but really climate change is a human problem. It is human created, and humans will bear the brunt of it. So natural systems have adapted over many years. It's easier for them to adapt when there are slow changes, but rapid changes happen and they'll come back. The Earth will persist. Human infrastructure is what we are concerned about. So we have had our entire civilization built at a certain temperature threshold, so this lower temperature range. And we have never seen a rapid change like this. So things like where crops can grow, where our water sources are, the infrastructure we choose is all built to operate under specific climate conditions. So specific temperatures, specific amounts of precipitation. And we're now changing that. So for instance, crops. Crops have been domesticated based on temperature and precipitation regimes, but also the soil nutrients. So you can think, oh, well, the crops we grow in the Midwest, as temperature increases, we'll just grow them in Canada. But the nutrients are different in Canada. You'll have to change your crops. And that's expensive, and you don't necessarily own that land, right? So the actual farmers will have to change what they grow. And then we have water sources. So as I mentioned previously, there's less reliable precipitation, and this also goes into farming. So your irrigation is less reliable, and it doesn't, So, and then also drinking water, of course. Where you can get your water won't be distributed in the same way that it has been historically. And lastly, I want to note infrastructure. So we have built our entire infrastructure at the temperatures we've historically been at. Texas is a great example. Texas built itself for hot climates. So our pipes are fairly thin. Our electricity producing systems aren't made to withstand winter temperatures. So what happened when we got some winter temperatures, so some extreme winter temperatures, everything shut down, everything froze. Many hundreds, thousands of Texans were in the dark, and many without water for extended periods of time. So it's a great example of how infrastructure is built for certain climates, and then with climate change, we have to either change it, adapt to it rapidly, or mitigate climate change in some way, ideally both. And we'll get into that in a minute. I also want to give the example of in Siberia. So Siberia has some of your coldest temperatures in the world. Let me just point it out on the map real quick. So we're up here in Siberia. In 2020, they had a 100-degree day, so 100-degree Fahrenheit day. They're not built for that. They're, even in the Northeast US, you have plenty of houses without air conditioning. They're not built for 100-degree days. And so that's what I talk about. And, it is like individual houses not having air conditioning, but also the roading we've chosen, the concrete we've chosen is all built for specific temperatures, and those are changing. So that's what I say when I mean humans have created it, and humans are the ones vulnerable to climate change. So we have a human-caused problem that primarily impacts human systems. But fret not, there are things we can do. So what are our options? The options are put into two main categories, mitigation and adaptation. And I want to say right now, these work together, not apart. We need to do both and for our current system. So let me start with mitigation. So mitigation is all around reducing and stabilizing the levels of greenhouse gases. These are things like electrifying transportation, building renewable energy systems, whether that's wind, solar, nuclear. And then on an individual level, it can be using public transportation or biking or walking instead of driving, eating less meat, using less plastic. Carbon capture, so I know Dr. Polk, I forget if she lumped it in mitigation or adaptation. The general consensus is that it's kind of both. So with carbon capture, greenhouse gases out of the atmosphere, which is also kind of adapting to the climate that's in the pipeline, which is a form of adaptation. So adaptation is changing our activities to line up with climate change that's already in the pipeline, like I just said. So that's currently occurring or will occur in the future, regardless of our actions. I want to note here, I already kind of noted it, that plant and animal species naturally adapt to cope with change. Some natural adaptation strategies are migrating or genetically evolving, and you're seeing that now. You'll see some plants and animals undergo selection based on heat tolerance and things like that, drought tolerance. But they absolutely do better if the change is slow. So this rapid change does make it harder for them to naturally adapt. For humans, some examples include building infrastructure that withstands climate futures. So things like seawalls to cope with flooding and hurricanes, reservoirs to conserve water for dry periods, updating buildings to deal with extreme climates. So putting cold-ready pipes in Texas and prepping our energy systems for freezes. This could also include farming strategies, so adjusting crop planting dates, which crops you plant, planting genetically modified varieties, using different types of more heat heat-hardy livestock, and also managing water differently. Kind of on the more extreme end is finding additional sources of income or migration. So in some scenarios, the source of income, say you're a farmer, but you can no longer farm on the land you used to, you might need to diversify the type of income source you pull in. And really extreme cases mean migrating for part or all, or either temporarily or permanently for jobs and resources. And we will see more climate migration into the future, and that is part of our social system that we need to prepare to see, which is, of course, outside the scope of this class. I want to note with these, all of these are expensive. Building infrastructure is very expensive. Migrating is expensive. Changing your farming strategies are expensive, and knowledge, you know, there needs to be a lot of knowledge that goes into that. So every individual community, state, and nation can't necessarily afford these strategies. And that's something we need to think about when we talk about the equity of climate change adaptation. And this brings me to vulnerability. So I was just talking about this bottom part right here, the adaptive capacity. So how ready an individual, a community, a state, a nation is to respond to climate change. Like, are you in a community where, you know, if your farmers can no longer grow, are you ready to give them seeds? Or do you have other income sources available? That's all falls under this adaptive capacity. And we already talked about exposure, so how they're, depending on where you live, you will see different effects. You'll see increased drought or decreased drought or increased temperature. So the exposure is spatially variable. And then also sensitivity. So this goes into both. So this is very much a social element. So whether people are more or less exposed based on their social factors. So you can see here things like household and community characteristics, quality of housing. So when I was talking about air conditioning and things like that, if those are already built in, you're less sensitive to climate change. Or if you already have an irrigation system built in, you're less sensitive to climate change. So those all come together to what we call climate vulnerability. So how vulnerable is an individual, a community, a state, a nation to changing climates? And vulnerability varies in time and location. We've been talking a lot about the spatial aspects. Of course, I'm a geographer, so I always think about space, but it's also true about time. And then also across communities and within communities. So even within, say, Austin, you have some communities that are more or less vulnerable to changing climates. And we saw that with the winter storm, for instance, that some parts of Austin were much more vulnerable and much more impacted. And some, you know, had the money to fix their systems immediately. So we have to particularly consider historically marginalized groups in this case, so communities of color, low-income communities, and immigrant communities, especially newly immigrated populations without existing social ties, when we think about climate vulnerabilities, especially within a community. So this is why Austin puts equity at the forefront of its newest climate plan. So I mentioned in the intro, this was adopted in September 2021, and you'll see it is the Austin Climate Equity Plan. So it's all about how do we mitigate and adapt to climate change while taking into account the social elements of communities. So at its basis, it hopes to reduce greenhouse gas emissions because it recognizes that our community will see extreme weather events into the future. So this graph depicts the five major greenhouse gas emitters and their trend from 2010 to 2019. So you'll see that our electricity has actually become more efficient over that time. Transportation has gone up a little, but then dropped. So this is due to the growing population in Austin mostly. And then electrifying of buses and vehicles is likely accounts for that drop there. And then more variable amounts when we talk about industrial, refrigerants, and waste. Let me see what else I wanted to say. So, and then on this side, Texas in general, not necessarily Austin, but in some cases including Austin, sees many of the main climate change extreme events. So you have extreme heat, we know that for sure, drought, wildfires, often along with the drought, right? Hurricanes, tornadoes, and blizzards. So those all occur in Texas. Even blizzards will occur in, Northwest Texas. And, with our extreme freeze, we saw some of the extreme cold here as well. So to reach its goals, Austin put in place a focus on 5 sectors with a commitment to equity throughout. So you'll be looking in depth at the goals of one of these sectors. So you'll be asked to pick one and look at the goals and strategies towards reducing greenhouse gas emissions while maintaining community equity. And while you're doing this, I want you to think about co-benefits. So what I mean by that is a really simple one. When you reduce greenhouse gas emissions, you also decrease pollution. I saw a study actually yesterday. It recently came out that found that if we all switched to renewable sources of energy away from fossil fuels, it would mean over 50,000 lives saved. So over 50,000 less premature deaths due to pollution. And there's a spatial element to that as well. But in Texas, we have a ton of oil and gas production. So a lot of those premature deaths occur in Texas, and we need to think about that. I digress. So co-benefits. You have reduced greenhouse gas means reduced pollution and also energy independence. When we talk about wanting energy independence, whether that's at a community, national, or national level, state or national level, renewable energies are kind of the way to go. The sun will always be there. Wind is predictable. All of these things can lead to energy independence. Of course, there is a monetary cost associated with that shift. So there are some cost and benefit implications there. So generally, I just want you to think about how what are the costs of these various goals and strategies, and then what are some co-benefits of them? What are some outside benefits? And I think the plan talks about a lot of them, but I do want to highlight that here. Also, this plan recognizes the shared climate action responsibility between governments, businesses, and individuals. So as Dr. Polk mentioned, a focus on individual actions can be a little sticky, right? If you focus too much on individual actions, you're also kind of putting the blame on the individual, right? If you're like, oh, you need to eat less meat, does that mean that you eating meat in the past led to climate change? No. So there are other entities that are equally or more responsible for causing and addressing climate change. But I think there's this balance between recognizing that the blame isn't on the individual, but you can help make a difference. So individuals do matter. So when many individuals start making changes as a collective, we see additional action, both through the additive power of our carbon footprint reduction, but also through corporations and governments realizing that climate action is popular. So you're starting to see more of that now. Even oil companies are becoming energy companies and switching to more renewable energies and clean energies because they see that's where the demand lies. That's where the future is. So in order to decrease our carbon footprints, we need to know what our footprint is and which aspects of our life are contributing to it the most. And that's what the second part of this lab is about. You'll use this tool that nature.org created to calculate your carbon footprint. And so once again, as I mentioned in the intro, I will then compile all of our footprints and we can look at each other's. I won't include names, of course, they'll be anonymized. And it will also suggest ways in which we can adapt. So whether that is eating or doing meatless Mondays or biking instead of driving to the grocery store that's half a mile away, things like that. I do want to stress that the most important thing you can do to act on climate change, so this has been well studied, is to talk about it. Talk to your friends, talk to your family, talk to your representatives. So making climate mitigation and adaptation popular so you and others will act towards better future outcomes is the best thing you can do. And so as Dr. Polk said at the end of her lecture, this topic can seem like doom and gloom, but there's also a lot of hope. More people are recognizing the problem and acting, and not just people, not just individuals, businesses, governments worldwide are noticing the problem and acting. And maybe sometimes it isn't as quick as some of us want, but it's happening. And I actually always really enjoy teaching this lab because engaging with you all on all of these things we can do really gives me a lot of hope personally. So on that note of hope, best of luck in the lab, and I'll see you in the next video.